Hi, thank you for that introduction. I'm responsible for Dell EMC's server storage architecture. So today I want to talk about the factors affecting that growth for NVMe, in this case for servers. Now I think it's fair to say that conferences like this also aid in the growth of NVMe, so I think we ought to take credit for this conference itself and all the participants that have been involved in it. Now, as I go through this presentation, I've kind of divided it into what are the technology trends that are aiding NVMe naturally in the case of flash memory and other different types of memory technologies. And then I'm going to go into some of the areas that we're driving on the server side to help the growth of NVMe. And then lastly, I will summarize with some of the challenges and what are the opportunities that we see in these areas. So let me start with the technology trends. So I think it's fair to say that whenever you look at flash today, the industry itself has done a great job of making flash denser as well as more cost effective. And that's one of the benefits where NVMe comes into play. Whenever you step back and look at NVMe, it was mentioned that we talk about lower latency and better performance. And I think whenever you look at that, NVMe has what I would call unleash the power of flash, because we saw that in the past that SATA and SAS, whereas they were becoming faster and faster, they still didn't quite address the natural benefits of flash. So also there are technologies advances around the cost, and so we see that in the case of as the volumes increase through market dynamics, and there's also just the cost benefits that come into play when you look at the benefits from our manufacturers themselves in producing cheaper flash. The capacity is increasing, and this is coming. It used to be that in the case of 2D NAND, we were looking at geometric shrinks. But in 3D NAND, which has actually allowed NAND to become more performant, mainly on the write performance, we can see that this also is going to benefit capacities in the future. And also we see the advent of not just TLC, but also the possibilities of QLC, and this was also made possible by 3D NAND. Also, the die packaging is becoming increasingly higher and higher. I mean, in the past, we've been using mainly up to 8 die per package, and we're seeing 16 die packages, and we've even seen cases of 32 die. Performance is also increasing. As we look at flash, it is becoming denser, and in some cases we're seeing performance benefits, but it's not at quite the same level as it was in the past. But we are seeing that there are new types of memories, in this case, storage class memories, as you see with the Optane from Intel and other companies, but also see other types of new memories that are coming on board. Also, I should mention too that today we are shipping PCIe 3.0, but 4.0 is in the near future, and we're already making plans for Gen 5. The other thing is on the power levels, this is kind of a mixed bag. On one hand, we're seeing cases of like ONFI that are running at lower power levels, which give us an advantage there. I should say lower voltage levels that are improving the power. But at the same time, the amount of flash is increasing, so we're kind of seeing this kind of a wash effect that's occurring. So I'm going to jump into what are the areas that we're driving that are going to, we believe are going to expand the growth of NVMe. The first area is around addressing customer expectations. Whenever you look at serviceability, I think our customers have grown to expect the same behaviors as that they've had for SAS and SATA. They also want to have those same behaviors present at NVMe. So we've addressed, the serviceability aspect by enhancing in two ways. The first one is in the silicon. So you've seen in the PCI SIG, there has been a lot of effort putting in new capabilities such as port containment to help with serviceability. In addition to that, we're working with our respective OS vendors in order to support the serviceability inside of their drivers so it becomes more ubiquitous. The decreased cost, we talked about that in the case of flash, but in the case of inside the infrastructure inside of servers, we are seeing that we're having opportunity to decrease cost in those areas, in this case around PCIe, and this comes in two different forms. We have direct connectivity from the processors, which already have PCIe lanes, and as they become more plentiful, we have the opportunity to connect to those directly and not needing to have additional circuitry such as switches in order to connect to them. But of course, when we get to a large number of drives inside a system, we also have switches available to us to help us continue our by-4 connectivity to those drives. More data protection options. And what I'm referring to here is that in the past, we had our traditional types of data protection, in this case, RAID, or maybe just data replication. But when we talked about drives of the past, we were talking about standalone RAID, and we also talked about storage arrays. And now we start seeing an advent of SDS and other types of new data protection methods that have a more natural fit towards NVMe than past interfaces. Security. Security has always been a looming issue, and it's becoming more and more of an issue. Now, we saw this even with SAS and SATA, but we're also looking at what did we do in those particular interfaces, and also added that to NVMe as well. And if you look at today, you can see a lot of work being done around Opal and also some of the enterprise level security. Also, there's management. You've seen that there's a working group for NVMe MI that is addressing special management needs just for the NVMe devices. Expanding ubiquity. And I think if you look back and look at SATA, it was a protocol that was very ubiquitous. We had chipsets that supported SATA, and it made it very easy for a customer to take a SATA drive and add it to their system. We also are seeing that with NVMe. That was also being supported at all the different types of silicon controllers that us vendors such as Dell and our counterparts that are utilizing to connect to the NVMe drives. But it's also more than that. We look at whenever we introduced NVMe back in 2013, we were focusing on the enterprise space, but it quickly evolved into being supported into the client space and even into what we call the data center, which is the hyperscalers and the cloud and our cloud vendors. And what we're seeing here is that if you look at SAS and SATA was tended to be more focused on in the client space, and SAS was more focused in the enterprise. NVMe is unique in that it bridges those two areas, being one protocol that works in both classes. If you look at all the different OSs out there, every one of them has a native driver. And when I was talking before about serviceability, we're working with our vendors to support the serviceability within those drivers, within the respective OSs and from the different vendors. I mentioned increased data protection options as another example, and I've already talked about that for the different types of data protection that we're being afforded for NVMe, such as the SDS and your typical hardware RAID. The native fabric support for NVMe, Eric mentioned earlier about a lot of work that was done on NVMe over fabric in the support of the different types of interfaces, such as fiber channel, Rocky, TCP, and the industry is working towards consolidating which are the mainstream interfaces that we want to support in the future. Increased media choices. We already talked about flash, and we talked about storage class memory that are coming on board. This is just affording more flavors of NVMe devices for our industry. And so I think in summary, you can say that SSDs are converging on NVMe. And I counter that with saying that when you look at hard drives, we see those being converging onto the SAS interface as well as SATA. So when I look at consolidation, I see that happening in multiple areas. And the SSD form factor, I think for the past few years, we've seen new types of form factors being introduced to meet different types of niche applications. I think starting last year, the industry is working together to try to consolidate to a few different form factors that make sense. And I think this would be good for the overall industry, because when you step back and look at how volume plays into cost and standardization, having a smaller number of form factors is going to play into that. I'd also bring up that some of the incumbent form factors that are out there, such as SD and XD, are starting to add NVMe interfaces. On storage device interfaces, we all know that SAS and SATA have been around for a while, and now NVMe. We're going to start kind of going back and looking at where does it make sense to start looking at interfaces that need to be deprecated. And we think that SATA is going to be one of the first ones that are going to be coming to play. NVMe over fabric variants, we already talked about that, going from all the ones that we have today with Fiber Channel, Rocky, iWarp, and looking at where does it make sense to focus on. As Eric mentioned, NVMe over fabric and TCP. Modality of device ports. Typically whenever you look at going from a single port to a dual port, you're looking at additional cost. For those different types, for those classes such as enterprise that support them. So whenever we started down this path with U.2, the connector had the capability of supporting two different modalities. And we're starting to see companies adopt that. So you can buy a single drive and it operates in either mode. And this is going to help drive down cost even further. Okay. So that brings me to my last slide on challenges and opportunities. I bring up this one. This is one of my pet projects. It is about flash performance density. What we're seeing is that the flash vendors are doing such a good job on increasing the density of flash that when you look at the same rate of increases for the interface, they're not at the same level. So what's happening is that as you start adding more and more capacity, that's the only way that you can increase your overall performance. So what that means is that the entry cost of our drives are increasing every generational increase. And that's an area that we would like to see addressed. QLC, right now the industry has been putting a lot of focus onto QLC, and unfortunately it was not quite as easy as the movement from SLC to MLC and MLC to TLC. We're seeing that QLC has its limitations, and I think the industry needs to work together in order to look at what are the right metrics to encourage QLC to grow into. The last thing I want to see happen for QLC is becoming the next SMR in the industry. PCIe distance, I don't think there's any question that PCIe, as it becomes faster and faster, the distance is becoming more and more of a challenge. And that brings into the advent of NVMe over fabric, so that whenever you want connectivity between your server nodes down into your storage nodes, NVMe over fabric is going to be the interface of choice. Computational storage, I think this is an interesting one. I remember back in 2013 at the Flash Memory Summit that Micron came on and started to introduce the first topic, and we see that has morphed into this sub-industry about what can we do with computational storage. The last is the block to key value. I use key value as an example, but this also means object, and it also means file, and we're also looking at open channel. So I think these are all great areas to explore, but we also got to be mindful of bifurcating the industry in different directions on the drives. So that's the summary of my presentation, and I'll turn it over to Pure Storage.
Thank you. I missed an opportunity to push Jay off the stage there. I'll probably regret that later, but So as Jay mentioned, my name's Steve McQuerry, technical marketing engineer at Pure Storage, kind of work between customers and engineering to make sure things get done right. That's pretty much what I say I do. And as Jay mentioned, I kind of wanted to take a different approach. We talk about NVMe in the enterprise, and as part of the work group, Pure works through the work group, and other companies do as well to make sure that the technology is adopted. We kind of looked at it as we were, involved in this, and we started building the array as, well, what's the right thing to do when we're talking about all flash? And obviously, when you look at the protocol, you look at what it does, the type of benefits that it gives you, it was the decision that we made. So that was really a strategic decision from the very beginning. And Eric set us up perfectly as he talked about, NVMe all-flash arrays and the adoption and kind of why we made the decisions we made. So when we think about adoption in the enterprise, some of the things that Gary talked about as far as form factor, as far as the server having the capability, a lot of the early adoption was NVMe and PCIe cards, right? And then we started seeing form factors and drives as well. So it kind of lagged a little bit from an enterprise server adoption because there were some infrastructure changes that needed to happen there. Some of the early adopters clearly got ahead of that, and a lot of the vendors started doing that. So now you see a lot more 24-drive servers that support NVMe than you did 2 years ago, for example. But that life cycle of getting that into the enterprise, I think, has kind of slowed it from that adoption standpoint. However, with an all-flash array vendor, we've been able to kind of accelerate that. And obviously, we're not the only ones that do that. So looking at, what are we doing? We're optimizing for performance and capacity, and when we look at what the protocol does and what we're trying to do, it matches with our strategy. So as Jay mentioned, what I kind of want to do is look through a case study and talk about why and how we took the steps to go from, a SCSI platform to an NVMe platform. First thing we need to think about is what are the transports, right? When you think about NVMe as a specification, you look at how it actually talks to the different platforms or how it talks to the devices. There are essentially two types of transports. The in-system transport of PCIe, which is it's an RDMA, it is a shared memory type of transport. And this is the most common place we see it implemented in the way people are going to interact with it in a device itself. As you start talking about a storage array, obviously that becomes important to the in-chassis, in-shelf type of connectivity. But as you start looking across and being able to do end-to-end NVMe, you have to look at the fact that there are also other transports out there, specifically NVMe over Fabric. All right, so Eric talked about this a little bit in the adoption and the places that it can go in the enterprise, and we're starting to see more uptick of this, specifically around NVMe TCP. There's some NVMe Rocky and Fiber Channel as well. I think that's where that end-to-end connectivity to the client is becoming more interesting, but there are actually places these can be implemented in the system prior to doing them in the client. And it's really the culmination of all of these standards at the times that it happened that allowed us and other vendors to take advantage of building an NVMe all-flash array. And again, as Eric mentioned, there are two distinct types of all-flash arrays. There are the very much performant, right? And then there are the mainstream that kind of exist out there. And they serve two different types of application workloads for the most part. So if we think about what does it take, right? So if you go back to the M class in pure flash array, or you look at other vendors where they were still doing flash, but they were using SAS SATA drives or using the SCSI protocol, that was what was available. So when you start looking at what does it take to take the next step, you have to start providing the NVMe capabilities within the array chassis. So if we go way back in history to Pure Storage as we came out of stealth mode and we started shipping flash array, the flash array 400 was actually commodity hardware, right? We didn't start building our own flash arrays until the M series. And that kind of presents some challenges, specifically back to what I was talking about with server adoption. If you want to do NVMe in servers and 24 drives in your data center, you have to buy new platforms. So we were reliant on that off-the-shelf technology to be able to do that, which is part of the reason we went into building our own hardware, was we started going into Flash Array M. As we moved to X, we made that decision. We're going to support NVMe across the board for all of those platforms. Again, to Eric's points, you set me up perfectly for this, right? It was a business decision, but it was about where the market was going and what the customers were looking for. So we started making that decision. And then when we started building the chassis, it became easy. We've got control of the chassis, we've got control of the mid-plane, we've got control of what we plug into those. So we enable NVMe. We enable it in the software, as other vendors do as well, so that now the protocol translation is from Fiber Channel on the back end. And from the user's perspective, it's simple. You bring the array in, you plug it in, it's fiber channel, it's iSCSI, it's what you're always doing, nothing changes in your infrastructure, yet you're able to adopt this new technology. And it gave us performance benefits. So we could go from our M-class flash array and talk about our X-class and talk about what it did for the applications and show actual benefits for the applications. I think at first customers didn't really care, right? They were like, okay, if it's faster, it's better, the price points are the same, we're happy. But now when we have conversations with customers, they ask about NVMe. They ask about NVMe over Fabric. It's become very much mainstream in what they expect when they're doing all-flash arrays or flash drives. I think the mindset has kind of changed from why would we do SAS or SATA on a flash drive, right? In the past, that wasn't really the mindset. It was, hey, flash is faster. Now people understand the benefits of NVMe as it applies to flash. So in the chassis is interesting. In the chassis is easy, right? What about outside of the chassis? So this is where I talk about as the standards come into play, right? As we start to see NVMe over Fabric evolve, we were able to take advantage of that. Now, again, to some of the points that Eric and Gary both made, NVMe over Fabric is a little newer when you look at the standards and you look at the specifications. So with the early all-flash vendors that were doing things like E8 Pavilion data, some of them, they had that proprietary stack. In the enterprise, that's not always great. It's definitely not great for all of your systems. It may be great for a few applications, but it's not great for everything. So NVMe over Fabric, in my opinion, and Jay may fight me on this later, has really become mainstream in 2019. I think this is the year we're really starting to see it really mainstream as far as where the inbox drivers are, the lack of needing a lot of proprietary stuff to make it happen. But prior to that, we started using it to expand into our shelf. So if we're going to connect a shelf to an all NVMe flash array, we wouldn't want to do it and do a protocol translation back to SCSI. So we used NVMe over Fabric, specifically Rocky, to provide a shelf to connect that. So we continue the NVMe experience. We're not doing any translations. We have nothing inside of the system that's not native NVMe. Again, this is a case study for Pure. There are other vendors doing the same types of things. The next step is to the host, right? And this is where things get very interesting. What are the benefits to the host? Well, it becomes a latency play when you talk about deterministic fabrics, right? When you're looking at a deterministic fabric, then you know what the latency of the fabric is going to be, and then you can reduce it because you are reducing the overhead. You're reducing the overhead on the host. You're no longer doing protocol translations on the back end. You're able to keep things streamlined, and you're able to take advantage of all the benefits that an NVMe over Fabric offers you. What's interesting about this, though, is what is the application? Where do customers want to see this? So when you look at NVMe over NVMe RDMA protocols, Rocky, IB, iWarp, et cetera, those have been around for a while. Fiber Channel's been around, it's been working on a while. The standard was actually ratified last year, and then NVMe TCP also last year. The real lack is not the standard now. It's the actual OS on the host. This is kind of what's holding back NVMe over Fabrics. Linux, by far, ahead of everybody. NVMe over Fabric from a Linux perspective, 7.6 and above. From a Red Hat kernel perspective, things are good. You can do inbox. You're not loading a lot of special drivers. Things work the way you expect them to. However, VMware, Windows, other operating systems in the enterprise still tend to lag behind that. So we're still waiting on some of that adoption. But as you provide that connectivity to the host, right, we're basically just extending the NVMe that's in the device, in the array as an NVMe device over that fabric. So it doesn't really distinguish the difference between local NVMe block devices or over fabric, other than the name, the device list will show you that there's a controller involved. What this means for the customer is they're able to utilize it just like they would anything else, right? What we're seeing in adoption is the front end fabric, the front end protocol is going to depend very heavily on what the application is. Rocky is one of the things that we offer today. It's the first of our offerings. Other vendors have done Fiber Channel first. I think what we'll see is that all the vendors will do all three. TCP is very interesting. We have a lot of conversations with customers about NVMe TCP, and I think it's because of that ubiquity. It's because of that ease of use. But to the point of most customers want that deterministic reliability when they're looking at their storage arrays or they're looking at their connectivity to storage. That's the one thing that we're going to be seeing about TCP is how is that going to play out? Whereas Rocky Fiber Channel can be much more deterministic. So kind of in summary, and I know I kind of rushed through this, I want to make sure we've got the time to do some questions, but kind of in summary here, when we look at utilizing NVMe in the enterprise, a lot of times it will get adopted through the appliances first, through what the vendors do. What we've done at Pure Storage is not unique to what other vendors have done. It's just that in some instances we were able to take advantage of it quickly because of the way our strategy was built. I think NVMe over Fabric is going to become much more interesting. I think it's something we're going to see a lot more of. 2020 is probably where we'll see a lot more mainstream from other ecosystems, and I think that's what we're waiting for from the host side. So, thank you.
I was waiting for him to do it. So we've had some really fascinating conversation. We have 5 minutes of questions. Yeah? 5 minutes?
3 now.
3.
Sorry.
It's my fault. I completely misjudged timing. It's all my fault. Are there any questions we'd like to have? Because I have a question for Eric, actually. So one of the things that I noticed, if anybody wants to ask a question, they can. The primary reason why somebody wants to have NVMe over Fabrics, according to your chart, was that they want to have consistency in latency. However, you also said that there seems to be an interest in TCP. Now, TCP is not known for its consistency and latency. So in your research, what kind of reconciliation are you coming up with for those two seemingly opposite goals?
Yeah, so when that research was done, again, that was December 2018 when that survey was in the field. So NVMe TCP was something being talked about, but nobody had actually seen production versions.
Sure.
I spoke to a few people who were using pilot versions, and they had an idea about what the performance differential looked like. I think in this arena, though, a lot of it's going to depend on how much performance is good enough. So if the bar that they're comparing against is, the older kind of 10 gig Ethernet or iSCSI or something of that nature. So yeah, TCP is not as good as RDMA, but it's still a lot better than what they were getting.
Sure.
And I think there's one other thing that could also assist in this arena is we've seen a lot of activity around this SmartNIC idea just within the last 3 months with people introducing, Mellanox is talking about it, Broadcom. So that might also help in these environments. But I agree that if you absolutely need the lowest latency for NVMe over Fabrics, it's going to be the RDMA implementation. People seem to be well aware of that, though.
Okay, good. Any other questions? Yes, sir.
What security features are customers asking for other than mediating principal?
Let me repeat the question. So what security features are customers asking for other than the typical encryption type of thing? Did I get that right? Cool. Anyone?
One of the big ones is just erasure. Being able to quickly erase the drive once they decide to, end of life it. So crypto erasure is also one of the important areas that customers are asking for. I know it seems simple, but it's still very important. And I would add to that just being able to support multi-tenant capabilities. Oh. That seems to... is that better?
Oh, that works.
Okay. So what I was saying was along with the cryptographic erasure, also to being able to operate in multi-tenant environments is also critical as well, especially when you start talking about hypervised environments and also even into the cloud.
Kind of to add to that, wow, mine's working well. Kind of to add to that, at least from a client side, when we look at the Fabric, we see a lot of requests for authentication in an Ethernet environment, whether it's the IP or the Rocky. So I think those are features we'll see, whether they evolve through, the NVMe workgroup, or they evolve through just using standard things like we're using in IP today, like chat.
Any other questions? Okay, well, I'll give you enough time to run to your next your section. Scurry away, scurry away.